A very important deduction of this is that the differentiation of any linear polynomial ax plus b is always equal to a, where a and b are constants. This is a very important rule. It will help you a lot if you remember, okay, even later on, okay, where a and b are constants. As an example of this rule, let us say if I want to differentiate 5x plus 3. In this case, if you see that this is your a constant and this is your b, another constant. Okay, in this case, the differentiation according to this rule will be equal to simply a, which is 5. Okay, this is the differentiation of a linear polynomial. Another example can be ddx of, let's say, 2x plus 5 by 3. Okay, this polynomial is also a linear polynomial. And if you want to differentiate this, you can first divide, can have 2x by 3 plus 5 by 3, right? And then again, what you can do is ddx of, you have 2 by 3 into x plus 5 by 3. So this becomes your a and this becomes your b. This is a very important technique, okay, to differentiate. If the denominator is a constant, you can always use this technique. Now this, because ddx of ax plus b is equal to a, you can simply write this as 2 by 3. So the differentiation of 2x plus 5 by 3 is simply 2 by 3. Okay, will help you to remember this technique. Next comes another important rule, which is called the quotient rule of differentiation. Okay, quotient rule of differentiation means if you have a quotient of two functions, say if u and v are two differentiable functions, then how will you differentiate u by v? U divided by v. In this case, what you do is, there is nothing much to do except memorize this. First function you take as it is, differentiate the second, and then a minus sign, and then the first function u you take as it is, differentiate the second, and divide the entire uh, result that you get by v square. So ddx of u by v is v du dx minus u dv dx divided by v square. Okay, memorize this because you will be requiring this in the times to come. In most of the problems, we'll be using u into v and u by v. Okay. Now let us come to the geometrical interpretation of a derivative, or what you mean by dy dx. See, graphically, if I am to draw y is equal to fx if is a given function. Okay. If I am to draw this on the coordinate axis, plot the points and draw a graph of this. Okay, so let's say I'm getting a graph, say something like this, of this function y is equal to fx. Okay, then in this case, if I draw a tangent at any point, let us say I'm drawing a tangent at the point P, and let's say this point P is x1, y1. Okay, let's draw a tangent to this. Tangent will look something like this, right? Then according to the rules, first of all, the definition, let's say the definition, if I extend this, then this is the angle made by the tangent with the x-axis. Let's call this angle as psi. Okay, now if I want to find the slope of this tangent at the point x1, y1, then what I will do is I have the function y is equal to fx, right? From this, I can differentiate this function to get dy dx is equal to f dash x, right? Then if I want to find the slope of the tangent, remember the slope of the tangent at this point, because you will have different slope at different points. If you take another point here, and if you take another point here, you will get different slopes of the tangent. You can draw tangents to all these points, you will get different slopes of these tangents. But if I want to find out the slope at this point, slope of the tangent at this point, then what I am going to do is I am going to find out dy dx at the point x1, y1. Dy dx at the point x1, y1 is equal to f dashed, and you, instead of x you replace it by x1. So the slope of this tangent at the point x1, y1 is f dashed x1. That is dy dx at the point x1, y1. Let us take a very simple example to demonstrate this. Let us suppose if I want to draw the, if I have a graph of y is equal to x squared. Suppose that this is the graph of y is equal to x, and I want to find the slope of the tangent at the point. Find the slope of the tangent to this curve at, let us say, -1, 2, or let's say a point on the curve must satisfy the point on the curve. Let us say I want to find out the coordinates of point at -1, 1. Okay, then how will I find out the slope of this tangent? Clearly, if you check, this coordinate will satisfy this equation. That means this point is a point on this curve. So we have, if you want to find out the slope, start with y is equal to x squared. So we have y is equal to x squared. Now differentiate this. That means dy dx will be equal to ddx of 2x, ddx of x squared. And what is the ddx of x squared? It is equal to 2x. So therefore, slope of the tangent to the curve y is equal to x squared at -1, 1 is dy dx at the point -1, 1. Okay, and what is it equal to? 2x. What is the x coordinate here? -1. So 2 into -1. So the slope of the tangent at this point is -2. And now, if the from the definition of slope, if you remember in class 10, I told you the definition of slope. The definition of slope was that the angle made by the tangent with the positive direction of the x-axis. So if psi is the angle made with the positive direction of the x-axis, then you can write that this slope must be equal to tan of this angle. Okay. So I hope this is clear. You can proceed to the exercise then.
Yes, sir.
Remember this, this will be again of a lot of use in the times to come. Slope of the tangent. We will be using this later on also. Okay, let's see. First one. Part 1. Okay. Differentiate the following with respect to x or t or u, whatever the case may be. Depends on what variable is there, right? In this case, if you see, the function is in terms of x, right? So I say let fx is equal to, so the variable here is x to the power of 100 plus 2x to the power of 50 minus 3 into 7x to the power of 8 plus 20x plus 5. Okay. Now this is a product of two functions. So I can take this as u into v, where u is equal to x to the power of 100 plus 2x to the power of 50 minus 3. And v is equal to 7x to the power of 8 plus 20x plus 5. So therefore, if you want to find out the derivative. So ddx of fx is equal to f dash x. Let's say ddx of u into v first. Let me write f dash x first. Is ddx of fx the same as f dash x is equal to ddx of, now what is fx? Fx is u into v. This is just to show you, okay? Just because I'm starting this, that is why I'm just showing you the u into v rule. Later on, I will not be writing u into v. I'll be using the rule directly. Okay, what is this rule? U dv dx plus v du dx, right? So now you can put the values here. The value of u is x to the power of 100 plus 2x to the power of 50 minus 3 into the ddx of v. V here is 7x to the power of 8 plus 20x plus 5 plus, and then you have v. So you write the v as it is into the ddx of u. U here is x to the power of 100 plus 2x to the power of 50 minus 3, right? Now we'll start our differentiation. So x to the power of 100 plus 2x to the power of 50 minus 3. We write as it is. And now we start differentiating this. Distribute this differentiation over this sum. So you get ddx 7x to the power of 8 plus ddx 20x plus ddx 15, right? And for the second one, you write this as it is, 7x to the power of 8 plus 20x plus 5. And for the differentiation, you distribute the differentiation over this sum. ddx x to the power of 100 plus ddx 2x to the power of 50 minus ddx 3. Okay, so this will now be x to the power of 100 plus 2x to the power of 50 minus 3. And here what you do is, 7 is a constant, you can take it out of the differentiation, write it as 7 ddx x to the power of 8 plus 20 is a constant, take it out, 20 ddx x plus ddx 15. 15 is a constant, so its differentiation becomes 0. For the second one, 7x to the power of 8 plus 20x plus 15. And here you can differentiate x to the power of 100 by ddx x to the power of n rule, which is nx to the power of n minus 1. So 100x to the power of 99. Plus, again 2 is a constant, you can take this out, right? It says 2 ddx x to the power of 50 minus 0, right? So now this becomes x to the power of 100 plus 2x to the power of 50 minus 3. And here you have 7 as it is, and ddx x to the power of 8 is 8x to the power of 7, right? Plus 20. ddx of x is 1, so this simply becomes 20 plus. And now this as it is, 7x to the power of 8 plus 20x plus 15 into 100x to the power of 99 plus 2 into x ddx x to the power of 50 is 50x to the power of 49, right? So you are getting ultimately x to the power of 100 plus 2x to the power of 50 minus 3 into 56x to the power of 7 plus 20 plus 7x to the power of 8 plus 20x plus 15 into 100x to the power of 99 plus 100x to the power of 49. This. Okay. Now you can leave your answer as it is. Okay. Or you can multiply this entire thing and get this as 756 x to the power of 107 plus 2020 x to the power of 100 plus 812 x to the power of 57 plus 2040 x to the power of 50 minus 168 x to the power of 7 minus 60. Okay, and this should be your answer. Clear? Any question?
No, sir.
Now, this I have done by this method just to show you the u into v rule. Now, actually what will happen is that whenever you get a product of polynomials, it is always advisable to multiply the polynomial first. This is a better way of doing. Okay, this was just to demonstrate u into v rule, so I have shown you. Let's say if I want to do this by an easier method, a better method, and this applies, remember, only when the given function is a product of polynomials. Okay, it may be, in this case you have only polynomial product of two polynomials. You can have product of three polynomials, four polynomials, five polynomials. Howsoever number of polynomials you get, it is always advisable to multiply the polynomial first and then proceed. Okay, so this is a better way. So I have y is equal to the given function here is x to the power of 100 plus 2x to the power of 50 minus 3 into 7x to the power of 8 plus 20x plus 5. Now, above I have demonstrated to you how to use u into v rule. But as this is a product of two polynomials, and as I told you, it is always advisable to multiply the polynomial first and then differentiate. Okay, this is a better way of doing it. So if you multiply the polynomials, you are going to get 7 into x to the power of 108 plus 20x to the power of 101 okay, plus 5x to the power of 100 plus 14x to the power of 58 plus 40x to the power of 51 plus 10x to the power of 50 minus 21x to the power of 8 minus 60x minus 15. Okay, if you multiply these two, therefore now your task becomes a little easier, so that when you are finding dy dx, you are simply differentiating one single polynomial. 7x to the power of 108 plus 20x to the power of 101 plus 5x to the power of 100 plus 14x to the power of 58 plus 40x to the power of 51, 10x to the power of 50 minus 21x to the power of 8 minus 60x minus 15. Now you in order to differentiate, you split the differentiation into each of the terms of the polynomial. So ddx 7x to the power of 108 plus ddx 20 x to the power of 101 plus ddx 5x to the power of 100 plus ddx 14 x to the power of 58 plus ddx 40 x to the power of 51 plus ddx 10x to the power of 50 minus ddx 21x to the power of 8 minus ddx of 15. Okay, so now you want to differentiate each one. How will you differentiate? You can take 7 out of the differentiation, write this as 7 ddx x to the power of 108. Now I'm showing you each one step by step. So because this is our starting, you may do it directly, okay? But because I'm starting here, I'm showing you each one step by step. So 5 you can take out of the differentiation, right? That's ddx x to the power of 100 plus 14 ddx x to the power of 58 plus 40 ddx x to the power of 51 plus 10 ddx x to the power of 50 minus 21 you can take out, right? This has ddx x to the power of 8 and differentiation of 15 will be 0 because it is a constant. And now you can write this as 7 ddx of x to the power of 108 will be 108 x to the power of 107 plus 20 x to the power of 101 will be 101 x to the power of 100 plus 5 ddx x to the power of 100 is 100 x to the power of 99 plus 14, this is 58 x to the power of 57 plus 40 into 51 x to the power of 50 plus 10 into 50 x to the power of 49, and finally you have minus 21 into 8x to the power of 7. And now you can multiply all this, you will get the same answer, 756 x to the power of 107 plus 2020 x to the power of 100 plus 812 x to the power of 57 plus 2040 x to the power of 50 minus 168 x to the power of 7 minus, finally you have 60. You're going to get the same answer as in one. Okay, this answer, and you have this answer is the same. Okay, you have, I think I left out one term here, which is how am I getting this 60? I think I left out this term in differentiation here. Let's add it here. I have minus ddx 60x. So in the next step, this will become minus 60 ddx of x. And the next one will become 60 into 1. And you also have minus ddx 15. Okay, this is something that I left out. Okay, so as my intention to show you both these methods was that in this method I wanted to show you the u into v rule. Okay, and I got this as my answer. Okay, but whenever you, as I told you, whenever you have a product of two polynomials, here we have product of two polynomials. Okay, whenever you have a product of two polynomials and you want to differentiate it, it is always easier to multiply the polynomials and then differentiate. Instead of using u into v rule, try to multiply the polynomials and then differentiate. The task is going to become easier for you. Okay, so I'll move on to the next sum then. The next sum that you have here, question number 1, part 2. If you see, you have a product of 3 polynomials here. Okay. You have x minus 2 into x plus 3 into 2x plus 5. Now you can use your UVW rule here. Okay. So let u is equal to x minus 2, v is equal to x plus 3, and w is equal to 2x plus 5. So therefore dy dx, we write is y first. Therefore y is equal to UVW. That means dy dx is equal to ddx of UVW. And UVW rule, you know, is take first two, differentiate the third, then take the first and the third, differentiate the second, then take the first and the third, differentiate the second. This is UW dv dx, and then I guess should be UV, UW, and then VW, first, second, and third, du dx. Okay, so now put the values here. UV is x minus 2 into x plus 3 into the ddx of 2x plus 5. Take the first and the third, x minus 2 into 2x plus 5 into ddx of x plus 3. Okay, and finally take the second and the third, and then differentiate the first one. You have x minus 2. Okay, so here what do you get? X minus 2 into x plus 3, and ddx of ax plus b, as I told you, this is your a and this is your b, right? ddx of ax plus b, as I told you above, was simply a. This is into 2 plus x minus 2 into 2x plus 5. ddx of ax plus b, coefficient of x here is 1, so this will simply be 1 plus x plus 3 into 2x plus 5. Again, x minus 2, coefficient of x here is 1. This will again be 1. Okay, so you simply get twice x minus 2. You can multiply this here. Okay, so you get twice x square plus 3x minus 2x will give you x minus 6, plus, and you can multiply this here, 2x square plus 5x minus 4x will give you x minus 10, plus you have 2x square plus 5x plus 6x will give you 11x plus 15. Okay, and you can add these to get 6x square plus 14x minus 7. This is the required differentiation. Now, as I told you that whenever you get a product of polynomials, it is always becomes easier to multiply the polynomial first and then differentiate. So this was the demonstration of UVW rule. But however, if you want to multiply the polynomial, which is definitely an easier way, you can multiply these 3 polynomials, x minus 2, x minus 3 into 2x plus 5, to get your resulting polynomial as 2x cubed plus 7x square minus 7x minus 30. And now it becomes easier to differentiate. So therefore dy dx will be equal to ddx of all this. 2x cubed plus 7x square minus 7x minus 30. Right? Now you can distribute the differentiation, take the constant out, you get 2 ddx x cubed Let me know if you're if not able to follow. Plus 7 ddx of x square minus 7 ddx x minus ddx 30, right? So you will get here twice x cube. Differentiation is 3x square plus 7. Differentiation is simply 2x minus 7 ddx of x is 1 and ddx of a constant is 0. So we get the same answer, 6x square plus 14x minus 7. Okay. So whether you use your UVW rule or whether you use your direct after multiplication, you directly differentiate, you will get the same answer. And I prefer, whenever I get a product of polynomials, I will always prefer this method instead of using the UV rule. Okay, whenever you get a product of a, say, a polynomial and a trigonometric function, or a product of a polynomial and a logarithmic function, then you can use your UV into V rule or UVW rule. But if it is a product of all polynomials, it is always advisable to multiply all the polynomials and then differentiate. Okay, fine. So
Okay,
that's
sir.
it for today. I'll stop here.